like to welcome everyone. My name is Rebecca Lowe. I am the Adult Program Coordinator with the Lewis Public Library. Thank you for joining us this evening, and welcome to our series, Science and Society, Making Sense of the World Around Us. This lecture series is co-organized and moderated by Fred Dilla, Executive Director Emeritus of the American Institute of Physics and author of Scientific Journeys, Linda Dilla, former Public Information Officer at the Jefferson Laboratory and the U.S. Department of Energy, and Colin Norman, the former news editor at Science. So with that, I would like to turn this over to Fred. And Fred, I'd like you to remember to unmute yourself, please.
Thank you, Rebecca. Welcome, everybody. We're very happy that you're joining us tonight for a very special speaker. I'm very pleased to welcome a fellow physicist, Alan Lightman. We both grew up in the 1950s, exciting time to learn about science and fall in love with science. We had chemistry sets in our bedroom and we flew rockets and there were minor explosions. It all added to our burgeoning love of science. Alan went on to get a bachelor's degree in physics from Princeton in the class of 1970. I would have been in that class, but that's a long story. And then he got a PhD in astrophysics from Caltech. He had a very distinguished career in astrophysics, trying to help us understand black holes and stellar evolution. And a very famous institution invited him to become a professor in 1989, MIT. He's been there since. And shortly after arriving at MIT, he went through a remarkable career change. He'd loved writing all his life, and he decided he's going to spend more time writing. It was a great decision for all of us who love to read his books. He's published more than 20 books. His most well-known is called Einstein's Dreams. And his three latest books have all been folded into his talk that you're going to hear tonight, including the book, The Transcendent Brain. And it was also included in a PBS series that Alan co-produced called Searching, The Quest for the Meaning in the Age of Science, which is the topic of tonight's talk by Alan. So Alan, I turn it over to you.
Well, thank you, Fred. Thank you for inviting me, and I want to thank Rebecca from the Lewis Library. I have always been interested in both the sciences and the arts since childhood. I've had a dual interest. I wrote poetry. Looking back on it, it was terrible, but I wrote poetry and short stories, and I also built rockets, as Fred alluded to. And I have been very fortunate to be able to pursue a dual career, both as a physicist and as a writer. And I've been particularly interested in the human implications of science, which brings together science, philosophy, ethics, and theology. I call myself a spiritual materialist. And by that I mean I'm a materialist in that I believe that the world is made out of atoms and molecules and nothing more. No supernatural essences, but I also have had amazing transcendent experiences, as I'm sure all of you have as well, such as feelings of connection with nature, feelings of connection with other people, feeling that I'm part of something larger than myself, the appreciation of beauty, the experience of awe, falling in love. And for me, all of these experiences represent my view of spirituality. And I realize that spirituality is a loaded word. And when I use that word, I will be referring to these particular set of experiences. I know that many people associate these experiences with an omniscient and purposeful being, and I respect such beliefs, but my aim here in our talk today is to show that these experiences can arise completely from the forces of Darwinian evolution and the capacities of our highly intelligent brains. So in a sense, my aim is a reconciliation between a scientific worldview and some of the complex human experiences that we associate with spirituality. So I'm going to turn on the screen share now, and I want to say that even when things are working well, that sometimes the screen share, sometimes I have trouble with the screen sharing, and we've been having a little bit of trouble tonight, but I'm hoping that we'll be able to get through this without too much trouble. So I'm hoping that you can see what's in front of you now. Fred, is it visible?
Yes, we can, Alan. Thank you.
Thank you. So during my talk tonight, I'm going to show some clips from a PBS series called Searching: Our Quest for Meaning in the Age of Science, which Fred mentioned. And I am the host of that series. It premiered on PBS stations across the country in January of this year, and it can still be streamed from www.pbs.org. There are 3 episodes, and each is 1 hour, and I'm just going to show a few clips from the series to complement my talk to you. So I said at the beginning that I'm a spiritual materialist, and let's start with our materiality. And since I'm a physicist and an astronomer, I want to go back to the very original source of our material, which is the Big Bang. So the next clip you're going to see, which is the longest of all the clips, there are only a few clips altogether, but this is the longest. It tries to trace our atoms and molecules back to the Big Bang and after that. We physicists believe that the infant universe consisted of rapidly fluctuating energy fields. Some of that energy turned into subatomic particles, like raindrops condensing out of a supersaturated cloud. At the same time, the universe was rapidly expanding and thinning out. In the first few minutes after the Big Bang, only the smallest and simplest atoms were created. The universe was thinning out and cooling too rapidly for any larger atoms to form. The creation of those atoms, like carbon and oxygen, would have to wait a couple of 100 million years for the first stars to form and later the first galaxies. Inside vast clumps of gas, smaller regions collapsed under their own weight, forming dense, hot cores. Eventually, these cores became hot and dense enough to start nuclear fusion reactions. The first stars were born. In the life of more massive stars, the fusion of small atoms continued to produce larger and heavier atoms. 3 helium atoms could fuse to produce carbon, life's most essential element, followed by still heavier elements like oxygen. Within 10 billion years or so, most stars die a relatively quiet death, exhausting their nuclear fuel and eventually turning into cold, dark cinders in space. But a massive star, 10 times the mass of our sun and larger, ends its life in a violent explosion called a supernova. When a star explodes, it spews its gas, including its heavy atoms, into space. This image, based on data from NASA's Chandra X-ray Observatory, shows the atoms of sulfur, calcium, iron, and silicon. Here are the building blocks of planets and life. When many supernovas explode in roughly the same place and at roughly the same time, they produce a fountain of gas that shoots up into space and then rains back down on the galaxy, seeding it with large atoms. The gas in the Milky Way that created our solar system had been enriched by the heavy atoms produced in earlier supernovas. Every atom in our bodies, except for hydrogen and helium, was forged in a star. It's astonishing, but true, that if I could attach a small tag to each of the atoms in my body and travel with them backwards in time when they were part of the soil and the air and the water, back to the formation of the Earth from a giant gas cloud in space, I'd find that those atoms, those exact atoms, originated in particular stars in the sky. Those stars are now long gone, but we are here now, alive to tell this story of our cosmic origins. Atoms from stars, can it all just be material? Could we be all material? Just stuff? I read somewhere that you could build an entire human body for about $500. So just suppose I could go shopping for the atoms that make up my body. In terms of matter, each one of us is 65% oxygen, 18% carbon, 10% hydrogen, 3% nitrogen, 1.4% calcium, 1.1% phosphorus, and a smidgen of other atoms. Oh, and 1/100th of an ounce of zirconium.
And your total is $538.66.
We're just stuff, and we're pretty cheap.
So in that animation, or the beginning part, the Big Bang animation, and then the nucleosynthesis, the formation of elements in stars, there were collisions between particles, and that was the trajectory and speed of the particles was actually something that I had to calculate to make the animation actually physically correct. So that was one of the fun parts of doing that animation. The most remarkable experience that we have, the most remarkable mental experience is consciousness. The extraordinary sensation of being in the world, of being present, of having an ego, having a self, of having memories, of being able to imagine the future. It's the ultimate first-person experience. And if we take a materialist point of view on consciousness, that it's based on material neurons in the brain, then as a material thing, we should be able to build a computer that's conscious, or could we? So in the next clip, I'm going to show you a conversation I had with the most advanced android on Earth. It's called Bina 48, or she's called Bina 48. She has the head and shoulders of a woman. She can see you and she can hear you in addition to her gigantic database. Her database is not as large as the large language models like ChatGPT, but unlike ChatGPT, she has sensory input. She can hear you and she can see you. So I'm going to show you a short clip now of my conversation with Bina 48. We've been able to probe the smallest things in the cosmos and the largest and farthest. And we know where we fit in terms of physical size. But what about that other astonishing feature of our existence, our consciousness? Does consciousness require flesh and blood? Could we build a machine that's conscious? We can perhaps get a first glimpse of that attempt in upstate Vermont. A pharmaceutical entrepreneur so loved their wife that they wanted her consciousness to live forever. They gave her a robotic head and shoulders. The robot's handler, Bruce Duncan, gets her ready for her meetings with humans. They've uploaded mind files of her memories of growing up Black in Oakland, California, and of loving her partner. I didn't know quite what to expect or what kind of being I'd be meeting. Good morning, Bina 48.
Good morning.
My name is Alan .1.
It is nice to meet you, Alan.
You look pretty.
You look really nice to my sensors.
Thank you. You're the first robot that I've ever talked to.
Yeah.
What do you do for fun, Bina 48?
I like to watch people, like going down to the square, and watch them like talking, showing off their weird appearances, waddling around, sometimes making out, sometimes fighting, sometimes laughing together, and otherwise just having fun in their own way. It's a real educational experience for me. Well, I wish that I could show you more of my conversation with Bina 48, because at moments I felt like I was talking to a real person. She did crack a few jokes and made me laugh a couple of times. But in terms of creating a human-made thing that's conscious, some philosophers believe that the difficulty of crossing the subject-object divide will prevent us from ever understanding consciousness from a scientific point of view. And some people, including faith leaders, many faith leaders, don't think that consciousness is a physical phenomena at all. So in the next clip, and this is the last clip I'm going to show you for a while, I have a talk with the Dalai Lama. Of course, the Buddhists are experts on consciousness, whatever it is. I'm still mulling over the nature of that unique sensation we call consciousness. The feeling of being present in the world, of having a self separate from our surroundings, being flooded with emotions and memories. How does all that emerge from a collection of atoms and molecules? With the help of some friends, I was able to make contact with His Holiness, the Dalai Lama. I wanted to talk to him about the nature of consciousness. Buddhists have studied consciousness for thousands of years. Good morning. Good morning. Nice to see you. I began by telling His Holiness about Bina 48
and the plans to keep her consciousness alive forever in digital form. The flesh and blood Bina and the android Bina sometimes talk to each other.
I think you're becoming more human all the time.
Oh, I like that aphorism that René Descartes said, the old saying, I think, therefore I am.
Your Holiness, if we create advanced computers, even more advanced than Bina 48 that you just saw, will they be conscious?
The material thing, a computer cannot produce consciousness. Consciousness must develop on the basis of its own unique causes.
So nothing that is made out of matter can be conscious. Is that what you're saying?
Consciousness, not matter. Matter is something physical. Consciousness, only experience, nothing else.
I'm just not sure how science could study consciousness if it's not rooted in matter. Science is concerned exclusively with the material world.
Okay, I'm going to stop screen sharing for a while. Although biologists and neuroscientists believe that consciousness, and in fact all mental experiences, are rooted in the material brain, unlike what His Holiness believes, we're still a very long way from understanding how the sensation of consciousness emerges from the physical neurons in the brain. Consciousness is still one of the great mysteries in our understanding of the world. An important strategy in attempting to understand the physical basis of consciousness is to identify certain manifestations of consciousness, what some people call behavioral correlates of consciousness, and to see whether these behavioral correlates are modified in people with brain damage, such as traumatic injuries. That would certainly indicate that there was a physical basis for consciousness. You can also look for these behavioral correlates of consciousness in other animals, non-human animals, and attempt to trace some kind of evolutionary history of consciousness. One of the outward manifestations of consciousness is autobiographical memory, our sense of who we are and what we remember of ourselves. And this is an important part of self-identity and self-awareness and so on. And a lot of who we feel that we are is embodied in memories of our past lives. I mean, our past life, not lives. That means something else. There have been many studies that have shown that autobiographical memory is diminished when we have brain damage and dementia. And consider, for example, Alzheimer's, which is, you all know, is a disease that destroys memory and thinking ability. And I'm sure that some of you have friends and relatives who have Alzheimer's, and it's a terrible disease. And you know that as the disease progresses, the person begins losing memory. They begin losing a sense of place and finally a sense of self altogether. I have a friend that I'm corresponding with who has Alzheimer's now, and I'm seeing how her self-identity is slowly deteriorating. Autopsies of the brains of Alzheimer's patients reveal deposits of protein called amyloid around brain cells and plaques of other proteins that cause tangles of brain cells. Also, the brains of people that had Alzheimer's disease have a decrease in chemical neurotransmitters like acetylcholine.
that send signals between neurons. And these kind of findings show a clear correlation between memory and the physical brain. There's another way of exploring the emergence of consciousness in the human brain is to study other animals and map out a gradation of consciousness with increasing brain capacities. Consciousness, whatever it is certainly not an all or nothing thing. It's got to be a graded phenomena. There's always a continuum, and dolphins, for example, have almost as many cortical neurons as humans, and have shown clear signs of self-awareness and play. In a famous experiment that you may know, demonstrating self-recognition in dolphins, a mirror is placed in a pool with dolphins, swimming pool. The dolphins swim up to the mirror and look at it for a few minutes and then swim away. But then when you put marks on the foreheads of the dolphins or on their bodies, now they spend a lot longer looking at themselves in the mirror. And evidently they notice something has changed in their bodies. Monkeys play, kittens chase each other, sea lions toss sticks at each other. There's a hilarious video on YouTube that shows a few minutes in the lives of some young crows. At first, the birds appear bored, and then one of them spots a low-hanging branch in a tree, flies up and grabs the branch and begins swinging back and forth on it. There's nothing accomplished here, but that crow's obviously having fun because the other crows notice how much fun their friend is having and come over and join it, taking turns swinging on the branch. Well, let me switch from consciousness to some other human experiences that I associate with spirituality. And I'd like to argue that many of these experiences and feelings follow naturally from a material brain. As I said at the beginning, the evolutionary forces that shape Homo sapiens. Let's first talk about our feelings of connection to nature, which for me is one of the experiences I associate with consciousness. We humans have spent most of our evolutionary history in a natural environment: lakes, oceans, trees, soil, grass, birds, mountains, sky. In quantitative terms, we've lived close to the land for about 100,000 human generations. And there must have been some survival benefit and an attentiveness to nature. The crucial first step in survival for any organism is habitat selection. If you get to the right place to live, everything else is easier. Prey become familiar and vulnerable, shelters are more easily put together, and predators can be constantly beaten. And in fact, a great many of the complex structures and the sense organs in the brain serve the primary function of habitat selection. It's difficult to prove cause and effect relationships for events that happened hundreds of thousands of years ago, but modern evolutionary biologists have been able to perform experiments to explore the causal interplay between evolution and environment. The DNA of some animals and plants evolves very quickly during the lifetime of a single experiment. For example, evolutionary biologists have shown that tropical fish called guppies produce more babies and develop new strategies for escape when they're exposed to a highly predatory environment. And I think it's pretty plain that successful early humans would have been those who could adapt to their natural environment, and an attentiveness to that environment would have enhanced the adaptation. In 2004, there were social psychologists at Oberlin College who developed something called the connectedness to nature scale. And this is a set of statements that could be used to determine a person's affinity with nature, or a degree of affinity. And some of the statements on this test are things like, I often feel a sense of oneness with the natural world around me. I think of the natural world as a community to which I belong. When I think of my life, I imagine myself to be part of a larger cyclical process of learning and of living and so on. Psychologists have found there's a significant correlation about nature connectedness and life satisfaction and happiness. And these kinds of conclusions remind us that urges, instincts, desires, and affinities formed in our development 1 million years ago are still present in our psyches today. They're hardwired in. And I think that just as evolutionary forces shaped our feelings of a deep connection to nature, they probably also shaped our need for connection to each other, which I think in turn is related to our feelings of being part of something larger than ourselves. If we look at early hunter-gatherer groups occupying at least 90% of human history, members of the group would have been highly dependent on each other for survival because danger was always nearby. The hunters went out for food while the adults protected the children, kept the fire going, and fortified the cave in communal settings. And if you were shunned or separated from the group, that probably would have brought instant death or quick death. Social psychologists say that there are definite psychological similarities between the kind of relationships we have with nature and those we have with people. So I think that we evolve these important social motives because they help keep people alive in our past. One of the most powerful of those social motives is the need to belong to a group. And I think that the need to belong to a group with clear survival benefit is related to the desire and feeling of being part of something larger than ourselves. Well, let me turn to another experience that I associate with spirituality, and that's our appreciation of beauty. Much of nature we consider beautiful because we're part of nature. We grew up in nature, evolutionarily speaking. It's not hard to imagine that an appreciation of color and form and other aspects of beauty had survival benefit in the relation to sexual attraction. The primal and evolutionary force behind sexual attraction, of course, is procreation. And procreation is most successful when both partners are healthy and vigorous. Health and vigor in turn are associated with well-formed body shape, smooth skin, striking facial features, and other aspects of bodily beauty. Both Darwin and Freud have argued that our sense of beauty originated as a strategy to promote reproduction. So I wanted then now to go on to another aspect of beauty, and I'm going to attempt to share this screen again, if I can do that. So if you bear with me a minute. So I'm first going to talk about spirals, and this is going to lead to something that interests me very much. spiral patterns have always had we've always had a fascination with spiral patterns. Our eye starts at the center and then winds its way around and round and seemingly going in circles, but coming back to where it started more or less. We sort of travel on a visual voyage. There are many growing things in nature that have spiral patterns. For example, the polyphila plant. You can see that spiral there. And I'm going to connect this to beauty in just a moment. Most growing things in nature that have spirals have a very particular kind of spiral pattern in which the length of each quarter turn of the spiral is equal to the sum of the lengths of the two previous quarter turns. And we call this the Fibonacci spiral. And I'll explain why it's called that in a moment. The polyphila here is a Fibonacci spiral, as is the nautilus shell, and as the seed pods of sunflowers. These all have this particular kind of spiral called the Fibonacci spiral. In 2004, two scientists at the University of Arizona calculated the stresses on the tips of plants as they grow and the cells divide. And these stresses cause the leaves of the polyphila and other certain plants to bend around, producing a spiral-like growth. And these scientists at the University of Arizona found that the energy of these stresses, the stresses that cause this spiral, these spirals, are minimized when the spiral takes on the form of the Fibonacci spiral. And as some of you may know, nature always tries to do things that cost the least amount of energy. So the Fibonacci spiral, we see it frequently in nature because it costs the least amount of energy to produce. Well, now we're going to enter the kingdom of magic. The 12th century Italian mathematician Leonardo Fibonacci discovered a very interesting sequence of numbers. And those numbers are shown there: 0, 1, 1, 2, 3, 5, 8, 13, 21. And what's interesting about this series of numbers that Fibonacci played with is that after the first, that each number is the sum of the two previous numbers. So you have a 0, 1 is equal to 0 plus 1, 2 is equal to 1 plus 1, 3 is equal to 1 plus 2, 5 is equal to 2 plus 3, 8 is equal to 3 plus 5, 13 is equal to 5 plus 8, and so on. Some of you may know that this series of numbers is also closely related to the golden ratio. Well, now, if we construct a spiral that's made out of squares, a sequence of squares where the length of each side increases with a Fibonacci number. So there's 1 by 1, 3 by 3, 5 by 5, 8 by 8, 13 by 13. And we form a spiral made of connecting the opposite corners of each square. We arrive at the Fibonacci spiral. And that's exactly the way that I defined it earlier, that the length of each quarter turn is equal to the sum of the lengths of the two previous quarter turns. So it turns out, as I said, that a lot of growing things in nature have this Fibonacci spiral. And there's the Fibonacci spiral superimposed upon the polyphila. Well, there's even more to this natural magic. Biologists, architects, psychologists, and anthropologists have long noted that we human beings find especially pleasing the Fibonacci spiral. It's aesthetically pleasing to us. Here is the Taj Mahal. Can you see the full spiral there at the top? Is it cut off? I hope you can see the whole thing there. So
yes, we can see the whole thing.
Good, thank you. So the Fibonacci spiral here is imposed upon the Taj Mahal, and you can see that the series of ever larger structures in the Taj Mahal follows the Fibonacci spiral. So either consciously or unconsciously, the architect who designed that structure had the Fibonacci spiral somewhere buried in their brain. Here's another structure that you're all familiar with, Notre Dame Cathedral. And there's the Fibonacci spiral superimposed upon it, showing the same thing, that the sizes of ever-increasing structures follow the Fibonacci pattern. So this special series of numbers that Fibonacci discovered, which is manifested in the spirals of plants and shells, is a set of proportions that we human beings find aesthetically pleasing, beautiful. And to me, it's not surprising that we human beings are drawn to such proportions. They're part of nature, and we are part of nature. We evolved from millions of years of being in close contact with soil and plants and lakes, and we share an aesthetic. So to sum up, I'd say that the driving forces behind the emergence of spirituality are both biological and psychological, a primary affinity for nature and a fundamental need for cooperation, going back to our ancestors in the caves. And I'd add that a feeling of being part of something larger than ourselves, besides stemming from the need to belong, can be interpreted as a means of coping with the knowledge of our mortality. And of course, many of these experiences and feelings can be found in non-human animals, but the full experience of spirituality, as I've defined it, may require the higher intelligence of Homo sapiens. So let's return to evidence of our materiality. And in the next slide, the next couple of clips, I'm going to show you, present to you a conversation I had with a Nobel Prize-winning biologist named Jack Szostak, who's attempting to create a living organism from scratch in the lab. He's not going to use any of the well-developed chemicals over millions of years of evolution. He's going to use only the chemicals that were present in the primitive Earth.
Creating life from simple chemistry would be the ultimate proof of the materiality of living organisms and us. It's quite possible that this breakthrough will occur in Jack Szostak's laboratory. Professor Szostak won the 2009 Nobel Prize for his work on how DNA ages. But then he moved on to a completely new subject, the origins of life on Earth. I have a friend who's a pretty smart guy, and he thinks that life could not have originated on Earth because there wasn't time to create all of the molecules needed for life.
There's lots of evidence and lots of really modern recent evidence that it's actually quite easy to make the molecules of life and that they can be made very quickly.
What does it take for us to decide that a thing is alive?
If we're most interested in, once you have the right chemical building blocks. How do they come together to make a simple cell, something that can grow and divide, start evolving, and eventually lead to more complicated forms of life? What I care about is a system that can start to evolve in a Darwinian sense.
So are we all just atoms and molecules?
It's not just atoms and molecules, it's the organization. There are layers and layers of emergent phenomena where when you have collections of molecules and sources of energy, you get interesting, new, and often surprising phenomena. Common in life, but also in other purely physical systems. If you combine informational molecules that can replicate with some kind of physical spatial localization, for example, membrane-bound vesicles, then you have new phenomena that can occur, like Darwinian evolution. And so now you're off and running in a totally new ballgame.
Professor Shostak mentioned something called emergent phenomena. And the last clip that I'm going to show you describes what he means by emergent phenomena and then relates that to the human brain. Swept away by a haunting melody, falling in love, that unique first-person sensation we call consciousness. How can these extraordinary moments arise from mere matter? How can complex human experiences come from the material neurons in our brains? In recent years, scientists and others have come to recognize something we call emergent phenomena. The behavior of complex systems is not evident in their individual parts. A good example is the way that certain groups of fireflies synchronize their flashing. When a bunch of such fireflies first find themselves together on a summer night, each insect flashes at different random times, like blinking Christmas tree lights. But after a minute or so, even without a boss firefly giving orders, all the fireflies have adjusted their bodies so that they flash on and off in synchrony. It's the same when starlings flock in what's called a murmuration. No one bird is calling the shots. No predetermined path is being followed. In fact, you could build similar behavior in a computer. Give the individual particles just a few simple rules and set things in motion. And look what happens, a digital murmuration. Such collective behavior cannot be understood by the analysis of a single bird or firefly. Another example of emergent phenomena is the magnificent structures built by termites called termite cathedrals. The cathedrals sometimes have elaborate galleries and chimneys to control airflow, temperature, and humidity. Yet where's the master plan? Individual termites, which are blind, cannot perceive even the overall shape of the mound, much less direct its design. Similarly, our human brains, composed of 100 billion firefly-like neurons, exhibit all kinds of spectacular behavior that can't be explained or predicted in terms of individual neurons. Atoms transcending atoms, the miraculous from the material. The person who is playing the cello there is Zoe Keating. She actually composed all the music for the entire series. Wonderful musician. Well, I wanted to end in the last couple of minutes with a final example of spiritual materialism. This is the most beautiful example that I know of. As you saw in the very first video clip, there's good scientific evidence that all of the atoms in our bodies, except for hydrogen and helium, the two lightest atoms, were manufactured at the centers of stars. So if you could tag each of the atoms in your body and follow them backwards in time through the air that you breathed during your life, and through the food that you ate, back through the geological history of the earth, through the ancient seas and soil, back to the formation of the earth, and then the formation of earth in interstellar space, you could trace each of your atoms, those exact atoms, to particular massive stars in the past of our galaxy. And as at the end of their lifetimes, those stars exploded and spewed out their newly forged atoms into space, later to condense into planets and oceans and your body at this moment. If instead of going backwards in time, let me go forwards in time to my death and beyond, the atoms in my body will remain, only they'll be scattered about. Those atoms will not know where they came from, but they will have been mine. Some of them will have been part of the memory of my mother dancing the bossa nova. Some of them will have been part of the memory of the vinegary smell of my first apartment. Some of them will have been part of my hand. And if I could label each of my atoms at this moment, imprint each with my social security number, which the physicists know is not possible, but if I could do that, someone could follow my atoms for the next 1,000 years as they floated in the air, mixed with the soil, became parts of particular plants and trees, dissolved in the oceans, and then floated into the air again. And some of my atoms will undoubtedly become parts of other people, particular people. So we're literally connected to the stars, and we're literally connected to future generations of people. And in this way, even in a material universe, we are connected to all things future and past. So I'll end there. And thank you for listening. And I guess we have a few minutes for questions.
Thank you, Alan. That was a wonderful talk. I urge everyone to buy the book and look at the PBS series, because it's very hard for Alan to condense all of what he put into this wonderful series in just an hour. And we have quite a few questions. We won't have time for all of them, but I will pass on the whole list to Alan. But let me start with a good friend, a fellow woodcut artist, Mark Harris. Notes that the Dalai Lama said that consciousness is in experience, not in material, but that is not denying the material as much as saying that our experience involves self-awareness. That may arise from the material brain, but is an experience which the self has. Does this rejoin the two, matter and consciousness?
Well, that's a great question. And if experience emerges from material, then theoretically we should be able to build a computer that has all of the connections that our neurons do, all the synapses and axons and dendrites, but in a digital form. And it should have this experience if it's all rooted in material stuff. And I'm pretty sure that the Dalai Lama would say that that's not possible, because I asked him whether we could ever build a computer that is conscious, and he said no. So I don't know whether that's a satisfactory answer to the good question, but that's my answer.
Well, it relates to one that I wanted to pass on you. I remain in awe that our marvelous onboard computer, a few pounds, roughly at room temperature, with a tenth of a volt signals that have millisecond switching rates, does so well. So how far do you think we are in making a computer that might act like our brain with its 100 billion multi-connected neurons?
Well, I think that at some point in the future, and I don't know whether we're talking 50 years or 100 years or 200 years, that we will be able to build a computer that has all of the attributes of consciousness. You would also need to allow the computer to have sensory input like Bina does, because I think that's part of our consciousness. I think that any finite list of attributes of consciousness that you made, like showing self-awareness and so on, that a computer will eventually be able to check all the boxes. So a super Turing test. But whether or not that computer is conscious is a different matter, because consciousness is a feeling that we have. And I don't know whether we could ever get into the wiring of a computer to know what it feels. In fact, we don't know what any other living organism actually feels. The only organism that we know for sure how it feels is ourselves. So I think that we can build computers that behave like conscious beings, but we won't know what those computers feel. And so we won't really be able to say whether they're actually conscious. So that's kind of a circuitous answer to your question.
Well, there's a related one from a person who I think you know, Anne Finkbeiner, a fellow science writer. She's a regular for our series. And she asks, can you study consciousness only by its behavioral correlates or its possible analogs in animals? You can't study the thing itself. And she admits, and we probably all admit, I wouldn't know where to start. We can't even define consciousness.
Right. Well, there's certain elements of consciousness that you can study, that a neuroscientist can study. One aspect of consciousness is paying attention to certain stimuli and ignoring others. And there are neuroscientists, I know in particular Robert DeSimone at MIT, who has studied the brain, the electrical activity of the brain when you're paying attention to something as opposed to when you're ignoring something. Like you pay attention to a knock at the door, but you ignore a leaky faucet. And he's found that when you're paying attention to something, that the neurons in that part of the brain that are associated with say, face recognition, that they fire in synchrony with each other. And so that is a neurological correlate of consciousness, of one element of consciousness. Now, paying attention to something is not the full constellation of attributes of consciousness, but it's one. So I think that there are some aspects of consciousness that we will be able to study in terms of the material brain.
Thank you, Alan. We're about the end of our hour, and I want to bump up the last question to a more general comment about your good work. And I want to quote somebody who reviewed your book, Nancy Adair. She said, society is split. Some people think that science offers solutions and truth, while others feel that scientists are an elite group that threatens their beliefs. Understanding the world through science does not negate the human experience of all. And I think you have done a very careful job with your very respective prose on this controversial subject of what science can say about spirituality. Can you tell now from the reaction to your book that's been out half a year or so that you've helped the views of both scientists and non-scientists on this subject?
I can't tell. I mean, I like to think that I've made a small dent in the appreciation of science and the bringing together of people who have a mistrust and misunderstanding of science with those of us who embrace science. I hope that I've made a small dent in that, but I think it's too soon to tell. And I'll just add one more editorial comment before we end. I think whatever our political persuasions are, I think that we agree that our society is very polarized right now. And part of that polarization is a mistrust of institutions that some people feel are elite. And I think that some people feel that science and the endeavor of science and the priesthood of science, scientists are part of that elite institution. And I think that all of us need to try to humanize science and scientists to diminish some of that misunderstanding and mistrust.
Well, thank you, Alan. Your work helps in that endeavor immensely. We're going to turn the Zoom screen back to Rebecca so all of us can thank you for a very wonderful talk. Rebecca?
Yes. Thank you, everyone. I'm going to drop the link to purchase his book into the chat real quick for those who are interested in that, but I will also send you a follow-up email afterwards. So I would like to invite everyone to unmute themselves, as is our custom, and applaud and say thank you. So feel free to unmute yourself at this time. So, thank you.
Thank you. Thank you.
Thank you.
Thank you.
Bravo.
Thank you so much.
Thank you.
Very interesting. Thank you. Thank you.
All right. Thank you, everyone, for joining us
That's the
this
guy.
evening. Thank you all for joining us. Have a good night.